Hey, JK bro, if I'm saying that right, thank you. No, it's not really based on real cat. I just felt like making the cat orange. I have a channel points redeemed to where someone can make me draw something of their choice, so decided to draw an orange cat. I feel like I was doing pretty good on the head, and then by the time I got to the body, it was like, but oh well. This one I'm kind of curious about. When we get a system of equations, we have two unknowns. Well, thank you. Okay, well, let's try this one out, because it looks like it might be kind of fun. So I assume we need to try... Do we need to try long... Or do we just do the long division here and deal with having A's and B's? That might be it. Let's go with black marker for this one. So if we have P of x equals x cubed plus ax squared plus bx plus minus 3. Whoa. And so if we divide P of x by what? X minus 1, we get a remainder of 2. Joker, okay. Sounds good. If you have any specific questions, I'm happy to take a look at them too. But otherwise, I'm just going to be doing whatever problems I can find out there on the interwebs. So there's a remainder of 2 when we divide by x minus 1, and a remainder of negative 4 when we divide by x plus 1. I guess let's try the long division. I don't know how it's going to work with a's and b's, but let's try the long division with x minus 1 first. X cubed plus ax squared plus bx minus 3. Just wonder if there's a better way that we can set this up, but I don't... Something we should do before this step, but I don't see it, so let's just do the long division. So we need to make x cubed, we have an x, so let's do x squared. X cubed minus x squared minus, so we get a plus 1 x squared plus bx. This is where it gets a little bit weird. We need to make a plus 1 x squared, we have an x, so let's do plus a plus 1 x. So we get a plus 1 x squared minus a plus 1 x. Oh god. Okay. So then we get a plus b plus 1 x, right? So a minus is plus minus 3. So then we make a plus b plus 1 x, we have an x, so plus a plus b plus 1 minus, yeah, okay, that's good. A plus b plus 1 minus, so minus 3 plus a plus b minus 2. Okay. And we know a plus b minus 2 must equal 2. Oh, so, okay, that's the key, I think. Because we know that the remainder is, wait, is it 2? Yes, because it leaves a remainder of 2 when you do that long division. Okay, so that's where we get our, I think this is where we get our system of equations out. I was wondering if we had to use this in some way, but I don't think we use that. We can use it to check the answer after, though. So let's try the same thing, but now with x plus 1, and we'll set it equal to negative 4 at the end. Okay, I like that. X cubed plus ax squared plus bx minus 3. Okay, we have an x, we need to make x cubed, so let's do x squared. X cubed plus x squared minus, okay, yeah. So here we get a minus 1x squared instead. Drop down the plus bx. Now we have a minus 1x squared, and we have an x. Or we need to make a minus 1x squared, and we have an x. So let's do plus a minus 1x. So when we multiply that, we get the same thing, a minus 1x squared plus a minus 1x minus. Okay, and here we get, 1 minus a plus b? I think I'm doing my foiling right. Now we have 1 minus a plus b x. We have an x, so we need to do plus 1 minus a plus b. 1 minus a plus b x plus 1 times that. 1 minus a plus b minus. Then we get minus 3 minus all this. So we get minus 4 plus a minus b. I think we're okay. And we know that it's equal to a number that happens to be -4. That's interesting. We get 2 and 2 and 4 and 4. I guess 4 in the sinus flip, the other it isn't. So we add 4 to each side and we get a equals b out of this one. Okay. And if from here we know a plus b equals 4, then a equals b equals 2, doesn't it? So I assume that's our answer. I'm going to check it in Wolfram Alpha though, because I don't feel all that confident in it. And I don't want to do even more long division, and I don't remember how to do synthetic division off the top of my head, so I'll try plugging those values of a and b and telling Wolfram Alpha to do this division for us. Because polynomial long division is kind of annoying. X cubed. We get 2 and 2, so plus 2x squared plus 2x minus 3 divided by x minus 1. Check by multiplying. Oh! You're right, I could check by that too. Let me see. I mean, actually, that's also a lot of work to do by hand, though. Okay, remainder of 2. And then the coefficient of x is 3, which makes sense. I got a plus 1 times x, and a is 2, so we should get 3x. And a plus b plus 1 is 5. Okay, good. So that checks out with that one. And now for the x plus 1, we should get a remainder of -4. Come on. -4. Hell yeah. Okay. It's a neat little problem. Now, I do wish they posted their attempt or where they got stuck, but also, if they don't know how to start it, I don't really blame them, because it's kind of a weird one to figure out. To 2 and -4, respectively. From there, you have 2 equations and 2 unknowns, so you can solve it as a normal system. So I'll give them the high-level steps, but not actually how to go about doing this, unless they reply back. Oh, I messed up my formatting horribly. Rookie mistake right there. There we go. There is no... I noped out of that one, Jed. I probably still have the link pasted. No, I don't. I don't know what's in my paste now. I put it. Oh wait, I can still see it in chat. Oh, okay. So if you think you have a thought there, or if you think you have a thought, I'll happily hear it. I don't know if it's still unanswered by someone else. Let me go and check it quick. Okay, so they're just asking for more information, which that's kind of my question too, I guess. But it might be that you don't actually need a diagram. I don't know though. For now, I'm just gonna look at this one because it doesn't have an answer. So an x-intercept is when the entire function equal to 0. X squared plus 2x plus 1. That does factor to x plus 1 squared, so there should be an x-intercept at x equals -1. Maybe square root 1 minus 2x? Shouldn't involve x's. I'm gonna graph this just to be safe, but he made an algebra mistake somewhere. What's the problem? X squared plus 2x plus 1 over x squared plus 5x plus 6. The bottom's also factorable. So to be fair, so we should check that that doesn't factor also to -1 and try and make things weird, but it doesn't in this case. And yeah, it does just barely touch -1. Okay, yeah, so I am right. Oh yeah, just scrapes by it. Okay. So I want to make sure, because well, what they were saying was kind of weird, so I'll make sure I wasn't misunderstanding the problem. I was about to give a more complicated explanation for how you find the x-intercept. I'm going to give the simple version, though. Oops, numerator equals 0. Okay, so let's see if they reply back. Light work number 20. Okay. Oh, still typing. Okay, so it looks like they have or they're getting the radius of convergence for power series. I shouldn't say Taylor series. And they're testing the endpoints, which are -8, -8, and -10. For -10, it does work by the alternating series test because it's alternating and the limit goes to 0. For x equals -8, it does not work because it's not alternating. It becomes a p series where your p is too small. If I had a nickel for time, I had that problem. Because it's decreasing and it's, oh wait, yeah, its limit as n goes to infinity is 0. The version without diverges because it's basically a p series, p less than 1. If your p is greater than 1, then it does converge. If it's equal to 1, that diverges too because it's harmonic. So I'll say less than or equal to 1. I think you set up, okay, for this type of question, you set up 2 lines. One of them is for the plane from, actually, I see that someone typed in Mui, let me see. Okay, I just basically said what I said. Oh, they were a lot more specific, but it doesn't matter. Actually, Mui instantly got back to that person. Okay, so maybe it's for the better that they typed there. Okay, what's their work here? 21/5, where is that from? What, 2100 divided by 500? Oh, that becomes basically what I thought it would be. I thought you'd have to make, so one of them's going the opposite direction, one of the slopes had to be negative. That would give you a negative result though, which I guess doesn't make sense. Actually, would it? No, it wouldn't. Yes, it would. Never mind. Maybe if I set up in a different way, then maybe it would. I don't know, dude. I kind of hate these questions. I just want to see if what happens if I do it my way. Because I was thinking doing it a slightly different way. Wait, okay. So I was thinking we we were to quickly draw, like, I guess, time and distance from Los Angeles. Oh no, from Austin, because that's how the first plane goes from Austin to LA. I was thinking that you take that first plane and just make it more or less y equals 500x, or, you know, in this case, d equals 500t. So it just looks something like that. I mean, well, obviously the slope is going to be a lot steeper, but it doesn't matter. Then for the other one that goes the opposite direction, from LA to Austin, it starts out at 2100 for its y-intercept. And then has a negative slope going down like that, which is d equals minus 700 t plus 2100. And then you would equate these. And I wonder if it gives you the same answer. It actually might. Okay, Jed. I guess I'll get to the conclusion of this, because it shouldn't be too much longer. So now you equate these and see where they intersect. It might end up being the same exact thing as their work. That'll be their intersection point. Add 700 to each side, 700 t. 1200 t equals 2100. 21 over 12, which is 7 over 4. They get 21 over 2. I don't know how to... Can we estimate what makes sense? So I want to figure out if I'm more likely right or wrong. So I'm really not that confident. These questions are kind of annoying. So the first plane, it's 2100 distance at 500 kilometers an hour. Means it'll be about 4 hours plus, like a little bit over 4 hours for that trip. The other plane is only taking 3 hours. It's going significantly faster. So it should meet closer to Austin before the halfway point. 21 over 2 is actually, that's 10.5 hours. Neither plane even takes that long to do the entire trip. Okay, okay, so I think 7 over 4 is more reasonable. Because 7 over 4 is just under 2. It's, what, 1.75 hours, so. That's much more reasonable of a number. So if they did their same exact work, how would they modify it to make it better? If you just made the 700 negative, that's not good enough because you get a negative result, and that's certainly not right. But if the entire left side was negative, no, if just the x and left, ooh man, I really hate the way this is set up because it's it seemed like they were taught to do this in a specific way, and something went wrong here. And it's really hard to diagnose exactly what. If your initial setup was 500x minus 2100 equals minus 700x, that would be right. That's basically what I have. I'm not sure how you get to that from the table it's been set up. Okay, so let's look at Jed's thing now while we wait for that person. Jed, I got 7/4. So basically 1.75 hours. This is interesting to see. I don't think it's going to help the person asking the question, but that is cool. Oh, did I make a fraction mistake? No, you divide them both by 3. 12 divided by 3 is 4. Okay, so I didn't make a fraction mistake. Why did we get something different? You must have 21/9? You must have gotten a 900 there. 7/3? Dang it. How do you get 900? You know, 100 is wrong? $28? Why? That's... I forgot about that part of the question. Yep, thank you, Jed. 1 hour later, and so we make it the equivalent situation by basically adding on that much distance. Even got the... Yep. Okay, so... And actually, I'm gonna quickly edit my Discord answer. Oh god, I might need... Okay, so I'm gonna do that immediate fix, but I'm gonna need to rephrase that entire thing, I think, to explain that part. So basically, I completely missed the question said, this plane left an hour later. And in 1 hour, the plane travels 700 kilometers. And we can deal with that 1 hour later bit by making that t... We could make it t minus 1. And then it'll still factor out to be the same thing. Interesting. Or you could do it the more like intuitive. God, I almost made another mistake. You could do it the more intuitive way and just go straight to 2800 there, but I was thinking like if you start an hour later, you could just do t minus 1, 2, and then the math will work out for you. One day I'll do a problem right on the first try. Okay, so then we get 28 over 12, which is 7 over 3. So they divide by 4 now. All right, thank you both. Okay, so let me fix this up. Actually, I mean, this is still kind of true. Maybe because... No. You're right. Which I think is okay. At noon. Yeah, take that save away, Jed. There's no even way to do that. So, okay, is that 2 1/3? Yeah, you're right. So 2:20 p.m. So that's why they have this. Wait, did they ever say plane versus jet? A private plane in the jet? Oh, interesting. The 2 time zone changes. Is Austin 2? I guess it is 2 time zones over. No, it's only 1. Never mind. I don't know why I was adding 2 hours. When they meet? Oh, you're right, you're right. I'll let you do that math problem. It's just not even that much harder. Actually, should I just... maybe I'll just leave it at this. And wait for them to reply back. This is all true. And we'll just see if they get back. So I want to hear, I guess, more about it. This is the part that I mean, okay. I don't mind explaining this. I just like I'm throwing out the stuff that they did, so. And say the plane from Austin starts at the 0 point and travels at 500 km per hour. The jet from LA starts at the 2100 km point and travels the opposite direction, so minus 700 kilometers per hour. It also starts an hour earlier, which we'll have to compensate for. The problem you didn't know the trick is fair enough. When someone else wrongly simplified and went south. Oh god, that's the worst. But the problem that I'm working with this person on is the classic. I mean, usually it's with trains, but in here they're using planes. One plane leaves Austin going at one rate. The other plane leaves LA to Austin going at a different rate. What time do they pass each other? And so I made a stupid mistake because I forgot to include that the 1 hour later bit, but Jed corrected me, thankfully. So we have the answer, but we have to, we're trying to explain it to this person. And just before this, we were doing a stats question. Which I'm gonna check on after this. The plane from Austin, we can set up as y equals 500x, where y is distance from Austin and x is time. The jet from LA is y equals minus 700. Now, how should I do this 1 hour earlier part? Jet from LA would be y equals minus 700x plus 2100 if it left at the same time. Since it left an hour later in x's time, we have to do y equals minus 700 x minus 1 plus 21. I think that's the best way I have to explain it. 1600, it should be plus 700. You know what? I don't want to do it like this. $700 kilometers time, or kilometer per hour times 1 hour to its equation to get y equals minus 700x plus 2800. Oh, that might be... That's doing like the opposite way? I don't think we need to factor in the other plane. I feel pretty sure this is right, so I'm gonna go ahead and post it, but if I realize that I'm wrong, I'll apologize to the person and fix it. So I don't think we need to worry about the other plane for the setup of the second plane. I'm pretty sure this is right. We got a pretty reasonable answer when we did the actual math out. You might be doing it like the opposite direction, where you're thinking of adding 1600 to the first plane. I know these questions are always weird for me, but I'm pretty confident that this is right. I did. Oh wait, I erased it. I had an actual graph going. We did, or basically, I mean, on the back end, I did y equals, I mean, I used d and t for distance and time, but I did basically y equals minus 700 x minus 1 plus 2100, and that minus 1 is for starting an hour later, because it's a shift to the right of 1. I'm trying to explain that in a simpler way, though. Yeah. Oh shoot, this person didn't ping me, so I didn't see it until now. Like a pure math university. Oh, okay. That makes sense then. Actually, okay, so I didn't see this person had gotten back to me, but I'm not exactly sure how to reply to this. I wish they asked me if they didn't understand something about what I said, because I'm really not sure how to reply to this. I think I might just move on because I'm not sure what more to do here. Yeah, the thing is, like, with their like little chart up here with rate and time, multiplying them for distance, I like the x plus 21 over 5 part is, I don't know where that comes from, but the math kind of works out-ish. So it gets something that is basically what I'd gotten on my first attempt, even though it wasn't right. Actually, let me screenshot this song too, because I kind of like it. I remember I've heard it before. Okay. I think I might just leave this one because I'm not sure what more to say. Did they? I mean, I really want to say like they just missed some minus signs somewhere, but it's not that simple. Like I don't think this chart is even that helpful. Oh, and that gives you time. Maybe not necessarily the right time, but it does give you the time. Okay. That's a good call, Jed. Actually, that's definitely not the right amount of time. That gives you, you know, 4 point something hours, 21 over 5. That's not the time difference here. Okay, so maybe they did x plus 1 there. Hey, Cooks. X plus 1 might be valid. Okay, if we took their same exact work and just made this x plus 1 instead, what does that turn into? Not right still. If this was if they added 1 to this fraction, if it was 21 over 5 plus 1, that'd be 26 over 5. Which would give you 2600, but we needed 2800, didn't we? Yeah. We made this bottom one x plus 1. Maybe? That looks a little complicated, though. Okay, so maybe if I told them to make the rate here negative, this time to be x plus 1, no, x minus 1 for starting an hour later. We're nearly there. We need to get the 2100 in there somewhere, though. Actually, oh wait. Okay, if they kept everything the same and made that 700 negative, made this x minus 1, it'd be... Okay, well, let's actually try this out. So I'd love to make their work actually match mine rather than tell them to throw everything out. So I'm saying they should make... Okay, if they have 500... x plus 21 over 5 equals minus 700, x minus 1. Does this give us what we want? That's what I'm trying to figure out. No, because that gets subtracted. So, but if we do plus 1, I'm really reverse engineering this now. Like, I'm not even thinking about this in a math way at all, but I'm just doing whatever it takes to make the math work. I don't know, is this even gonna work though? No, because then the sign doesn't even match. I don't know, man. Who was the person I replied to? Psychomancer. They still haven't gotten back. Honestly, for this one, like, I told them that I don't understand what's happening in this chart, and I gave them like what the setup should be. It's hard for me to say that much more with this. Once I think of something later, I'm just gonna move on for now. Something dicey happened in this one, I guess. Oh, okay. It's been a while since I've done this. You have the election result. Use the equation for a confidence interval here. Okay, well, let me look up the formula for confidence interval with proportions. This is what we want. So we want the margin of error to be 1%, basically. So We define the z-score that goes with a 90% confidence interval, which I think is just gonna, since it's two-sided, oh god, I should remember that, but I think you go for the 95% mark. But I do want to look that up to be safe. Z's. Oh no, it's gonna search on Amazon if I start with Z. Oh my god. Confidence interval Z score. Oh wait, you do the 90% mark. What is it interval? Plain solution on Discord. Oh, okay, let's look because this one isn't urgent. Wait, I didn't remember to. What was the? Okay. Banana. That's how I'm gonna remember that. Help 9. This is a very fancy way of saying it, but looks like we did basically the same thing, yeah. Okay. Nice. Okay. I guess I'm glad I'm Googling this. .65. Where does that fall? Like, I just want to table Z score. Where's 1.65? 1.6. That is a 90. Okay, good. So my instinct is right. You do the 95% mark. Okay. So 1.65 is gonna be our Z score in this formula. I just wanted to. What the heck? Away. Sorry. So I think we have everything we need. And I think for P, when you do this, you take the worst case scenario, which is P equals 0.5. That gives you the most potential error. I should look this up too. Because it has been a minute since I've done these. I really don't want to give bad information. Calculating sample size for margin of error. Hopefully this gives me what I want. It's basically the same thing, but 80% confidence interval, geez. We want it for proportions. You gonna show me the proportions? You're not, you're just gonna conveniently avoid proportions. It's cool. See if I care. Okay, so this person does take 1/2. Just look at one more here. Yeah. Okay, now let's look back at their question, just make sure that we weren't given that information and that I missed it. We're good. Okay. So, plugging into the formula for margin of error, we get 0.01, the margin of error of 1%, is equal to the z-score, which was 1.65 for 90%. All right? Just being sure, I don't want to make a mistake this early, you know? 1.65, good. Times square root of 0.5 times 0.5 over n. And we want to solve this for n. This is more of a calculator problem, but we'll do what we can manually. Point five is 0.25. And okay, we can say that n equals 0.2. Oh, that's not a 2 at all. .65 over 0.01 squared. There we go. .25. Oops. 1.65. 0.01 squared. 6806.25. We round that up because you can't pull a quarter of a person, so 6807 is what I'd say the answer is. Just be absolutely certain that I didn't do something stupid with my algebra. Let's just plug in the initial equation too, because I guess don't trust my own mind to do math. Oh, you know, I didn't have to do 0.5 and 0.5. You could just... Okay, it's fine. 82.5. Oh, that's root. What is that? Is that the same number? 6806. Okay, good. Good. This person might not see it because it's been over an hour. I mean, they initially posted this 3 hours ago. But I'll still reply and hopefully they see it. I'm gonna take, what's this? Okay, I'm gonna take a screenshot quick. So I was about to write this out in LaTeX, but I'll just use a screenshot for the margin of error. .01. The value for z should be the value that goes with a 90% confidence interval. And for p hat, the usual practice, or unless more information is given, you typically do p hat equals 0.5, which is the worst case scenario in terms of variance. Which is assuming the worst case scenario in terms of variance. Now it's an algebra problem. to solve for n. So let's post that much and see what happens. Banana. Interesting integral. You could get the bottom to be all sine or all cosine using the Pythagorean theorem. Or Pythagorean identity. What do they do? The top looks like a half angle. They only posted part of their work? Well, this is kind of hard to read. Like, what was their U sub? Oh, it's over on the right side. Really? I don't know about this U sub. No, this is not right at all. They never figured out what dx and du are. Oh, because it ends up with x over sine x. Yeah. Oh my god. Yeah, that's not a fun one. So this person is saying u equals sine squared x. That derives to, oh, 2 sine x cosine x. And so then you just get minus 9 over u to the 4th plus 1 minus u to the 4th. Oh, that's what I even, wow, okay, this person's a genius. That's a really good sub, I think. That makes a lot of stuff just go away. Oh, no, never mind. It's not gonna be that simple. I think you still get a cubic with u's on the bottom. That's still the right answer, I think. All right, you know what? We've talked about this one enough. Let's just do it. This is just completely for fun right now. But if you do sine cosine, when you actually do the sub, you get like divided by cosine squared plus sine squared or something like that. Yeah. So the problem still isn't over there, but it's a lot more solvable. So I'm curious. I want to see what it looks like if you just start with the sub the person suggested, and then I also want to compare it to what Bob is saying and see what's actually easier. So if we just do right off the bat, u equals sine squared x, du is 2 sine x cosine x dx, and that gets a nice cancellation here and here. I'll bring the minus 9 over 2 outside. That cancels away entirely. 1 over u squared plus, by Pythagorean identity, that's 1 minus sine squared x squared. So we get 1 minus u squared squared du. And I'll just take this a little bit farther and see what happens from here. U squared plus 1 minus 2u squared plus u to the 4th du. Not looking too easy. Just do one more step. U to the fourth minus u plus 1 squared, which isn't even factorable. That's kind of ugly. So if we tried Bob's idea of simplifying this a bit first in the denominator, let's see how that pans out. Irreducible quartic, yeah, that'd be so annoying to do partial fractions with. So you'd have to do... No, can you even partial fractions that when it's just alone like that? No. I don't know what you do with that. Yeah, I'm not sure about that. Okay, so basically, Bob noticed that sine squared x plus cosine squared x squared is equal to sine to the fourth x plus 2 cosine squared x sine squared x plus cosine to the fourth x. And look, sine to the fourth x plus cosine to the fourth x is here, and it's also there. So we can also say that sine to the fourth x plus cosine to the fourth x is equal to that minus that, which is a very hard step to notice, for me at least, but it definitely is sound. I don't know why I'm writing cosine first there. What I did is not correct. I assume you mean over here for the quartic? I would believe it if I was wrong. I don't see what I did wrong, but oh, good catch. Thank you. So yeah, sine squared is already u, so I didn't need the second squared here. Thank you. So this becomes a much nicer problem. Well, it's still actually, is it still 2u squared? And it's 2u plus 1. It has to multiply to 2 and add to -2, so that's still not reducible. It's probably a lot easier, though, for being quadratic. Oh, you know, you could factor it, deal with imaginary numbers, but potentially, and do partial fractions with that. I think it might be a different way entirely? I don't remember how else you would do that, though. Okay, so that's still not an easy integral from there, regardless of how you're supposed to do it. If we investigate this idea more, what was the idea after this? Do we still take u equals sine squared? I think we do. So do we end up with the same exact thing? This is the difference of two squares. I don't think... Does knowing that help us, though? It actually might. Let's just try factoring it. I want to see how it looks. So wait, that's a square? Oh, it's gonna be a root 2, but that's okay. Oh, you're right. Sine squared. Okay, good call. Okay, that's a lot simpler than what I was about to do. Please. So yeah, sine squared plus cosine squared is 1, of course, and 1 squared is just 1. So this is actually 1 minus 2 sine squared x cosine squared x dx. And I imagine now you want to do a similar technique and use Pythagorean identity and do still u equals sine squared. I wonder if we get something different though. That is actually a half angle. I don't think that's particularly helpful though. There's also a half angle up here. Actually, could that be helpful then? You'd have to do the half angle twice. You get everything in terms of like, what, sine 2x? It'd be 1 minus, actually, maybe half angling is a good idea, but let's see how that looks. We also know that sine 2x is equal to 2 sine x cosine x. So this, we get minus 9 over 2 integral sine 2x over 1 minus, we half angle twice here. So we get 1/2 times 2 is 1, times 1/2 again is 1/2. Sine squared 2x. Right? Maybe that isn't helpful. Maybe we should just stick with that format. Because with that format, we can still do u equals sine squared. Wait, yeah, u equals sine 2x doesn't really help here. So we end up with a cosine. U equals sine 2x squared? Oh, it would almost work, but yeah, I think we want that cosine there. It makes the u subs easier. That is an interesting, like, format, though. Or wait, oh no, you have another idea? Turn sine squared into cosine squared. Oh, and then you do u equals cosine. Okay. There's an idea. One minus cosine squared 2x dx. Okay. I'm still not sure if it's going to be easier than our weird imaginary partial fractions, but... Oh, you know what? For something like that, you complete the square and then you do tangent. I remember now. That's still a huge pain that I don't want to do, but that is a technique you can do that avoids imaginary numbers. Draw some arrow spaghetti. Let's not forget our constant. Okay, yeah, so that's completing the square. That's right. So we know how we could integrate that, but it's still like a little bit annoying. So I still want to see if this like all the stuff with the identity is going to go anywhere with the different like trig identities. Just kind of fun. So 1 minus a half is a half, right? Right. Last I checked. Then minus a negative is plus cosine squared. du, or du, dx. Okay. Just making sure oh wait, 1/2. We need a half in there. Actually, let's factor the 1/2 out and put it in there, right? I'll make the numbers a bit nicer. Yeah. And then it's 1 plus cosine squared. Wait, and that we could put that back in. Wait. No, that's not sine squared. Never mind. I thought. Okay, never mind. The sign isn't right. The coefficient is 9. So I factored out a 1/2 from the bottom. Oh, I should have flipped it. Thank you, Bob. Yeah, if you have 1/2 on the bottom, it's like multiplying by 2. Not dividing by 2. Okay. So now we can do u equals cosine 2x. I have no idea if this is still even going to work. I'm just curious to see if it does. Okay, so now we get minus 9 roots. That cancels with that. Oh, and the over 2 comes back. Nine over 2, positive no. Now. Oh, that's a nice. I just marked myself. Okay. Ah, I don't know. My marker just like slipped. It's gonna be annoying. So now I have a marker on my shirt. My pants are okay though. That damn 2. Yeah, just keeps coming back. Okay, so that's just arctan, isn't it? I'm pretty sure, yeah. And then if we unsub, cosine 2x. I feel like that doesn't simplify though, does it? I know when you have the reverse situation like cosine of arctan, you could simplify that. Does this? Maybe it can. No, because the 2x is an angle. I think that's just your answer. I feel like it should. Does that? Well, no, I want to see if it matches. Wolfram Alpha? What do you say about this integral? That's fine. Fourth plus cosine x to the fourth. Hey, look at that. That's kind of a fun one. Great spot on that technique. It does avoid, I mean, I still don't know if it's necessarily, it does avoid the partial fractions and might still, it's complicated enough though that I might still, or not partial fractions, but it's because you complete the square into a tangent sub. So, I mean, I still don't know which one is actually harder, but great spot on that. It's worth a save too. We weren't like working on it. We were just doing this for fun, but a spot like that, you know, it deserves a save. Interesting. Just a for fun like tracker if you make a good call on a math problem. So like you, like zone probably has a bunch of saves. 5, yeah. Actually, we could check the Discord. Their answer got solved anyway, so we definitely don't have anything that we can add here, but... God, standard form? Ugh. Pythagorean theorem should be it, because it's basically the distance formula. Okay, so... let's work on this one. Tomorrow is going to be a gaming day, but yes, I'm going to be playing DayZ with Central. My next math day would be Thursday, but it's Thanksgiving, so and I have a turkey that I have to make that day, so I probably am not going to stream that day. So I guess I wouldn't be doing math until Saturday. I mean, I guess I could do the math on Friday too if I'm in the mood, but I think I'd probably rather game on Friday, like I normally schedule to. Preparing for an exam for elementary group theory? Oh, well, I definitely can't help you with that anyway. Group theory is not my strong suit. I don't know how the other like math streamers feel about group theory and abstract algebra in general, so I have a hard time like saying who even would. I'm sure it's like some of them like are good with it, and I just haven't seen them do it, so I'm not even sure. Okay, let me... I'm afraid the Discord chat is going to move and mess up my screen capture here, but let's just try it. I'll do this, why not? Yeah, and Suki seems like they can do a ton of different things, so they're definitely a good person to try. Okay, so we have a line in standard form. 2x plus 4y equals 5. And then we have a point. L is distance from the origin to the line. And we can use the distance formula for this. We do want to rearrange this. I'm going to solve this equation for y. You can solve it for x as well, but I'm going to do it for y because that's what I'm more accustomed to. I have over 4 minus 1/2 x. Okay, good. I still remember basic algebra. And now L, I'll use the distance formula for. We have an arbitrary point. An arbitrary point on the line x comma y that we want the distance to 0, 0, 4. So the x coordinate on the line is just x. The x coordinate of the origin is 0 squared, plus the y coordinate of the line is this entire equation, minus 1/2 x. And then the y coordinate of that one is 0 squared. Now we simplify this, and I think it's our answer. Oh, it does say right L is a function of x, so you do want to solve the equation for y in terms of x. Let's simplify this to see what we get. X minus 0 is x squared is x squared. Oh god, that's gonna be some annoying foiling. 25 over 16 minus 5 over 4x, if I'm doing that right? Because it gets multiplied by a half and then multiplied by 2, so it's just 5 over 4, I think. Plus 1 over 4x squared. This feels right. Now let's get the x squared combined. If I factor out a 1 over 16, that seems like a really good step, right? That becomes 25 minus 20x. That's 5 over 4. 5 times 4 is 20. We can factor out a 5 as well, make the problem a bit easier to look at. Actually, the 16 can come up way out front too. And we can bring the 5 out front just as long as it stays rooted. Root 5 over 4. 5 minus 4x plus 4x squared. Multiplies to 20, adds to negative 4. Does that work? We have 10 and 2. We have 5 and 4. No. I feel like they normally give you a perfect square for these types of problems. Keep the 5 in there? It does match with what the answer key says. Oh, I see what you're saying. Because we're trying to match what the answer key says. Thanks for spotting that, Jed. So yeah, they kept the 5 multiplied inside, but they did take the 1 over 16 out. And so from how the person wrote it in text, it seems like the correct answer is root 25 minus 20x plus 20x squared all over 4, like that, which is valid. Oh, and I was blocking it with the Discord, but yeah. Nothing that exciting anyway. I imagine they got pulled up on this realization here with what x and y are. So that's what I'm gonna focus on, I think. Oh wait, I need to downsize this. Okay. An arbitrary point x, y on the line. Okay, wait, so let's see. I'm just working on this person's problem. You didn't miss the whole time. It wasn't anything that that fancy. To get y equals 5 over 4 minus 1/2 x. An arbitrary point on this line x is xy, but since we know what y equals, it's also x comma 5 over 4 minus 1/2 x. From there, we apply the distance formula with 0, 0, and x comma 5 over 4 minus 1/2 x. It still works even if x's are involved. Boy, that helps the person. Let's see if they get back.